Hey everyone, and welcome back for another deep dive. Today, we're going to be talking all about space mining.
Ooh, exciting.
Yeah, we've got some excerpts here from a chapter called Survey of Space Mining Missions and Milestones. And it's going to be kind of like our roadmap, for how we went from like just dreaming about, getting rich off of asteroids to actually like bringing pieces of them back home.
Wow, that's right. Yeah, we've actually already got pieces of asteroids here on Earth.
I know, it's pretty wild. So before we get into like bringing home the bacon from space, right?
Yeah.
Let's rewind a little bit to the early days.
Okay.
What were some of those first missions like?
So these early missions were really like the pioneers venturing out, into the unknown.
Okay.
And one great example of this is New Shoemaker,
Right.
which launched back in 1996.
Okay.
And it actually became the first spacecraft to not only orbit an asteroid, but to actually land on one
Wow.
433 Eros.
1996. That's amazing.
Yeah.
I had no idea that we were landing on asteroids back then.
Yeah. Yeah.
What did we learn from Eros?
Yeah, so near Shoemaker sent back a bunch of detailed pictures and, analyses, and it showed us that Eros was really rich in silicates and metals.
Interesting.
So, it kind of gave us our first real glimpse into, the potential treasure trove that these asteroids hold.
Okay, so not just space rocks, but like actual potential resources.
Exactly.
Ugh.
And even missions that weren't, specifically designed for mining ended up, giving us some really valuable knowledge about asteroids.
Okay.
So like take the Deep Impact mission in 2005.
Okay.
Now that was primarily aimed at a comet,
Right.
but it taught us a lot about like how to actually manipulate the surfaces of these small celestial bodies.
Which I imagine is really important if you're actually thinking about like, digging stuff up out there.
Absolutely crucial.
Okay. Yeah. Starting to see how these early missions, fit into like the bigger picture here.
Yeah.
But let's get to the good stuff.
Okay.
The sample return missions.
Oh, right.
So who like actually pulled that off first?
That honor goes to JXA, the Japanese Space Agency, with their Hayabusa mission,
Okay.
which launched in 2003.
Right.
And it targeted an S-type asteroid named Otokawa.
Okay.
And S-type means that it's mostly made up of silicate materials,
Gotcha.
kind of like Earth rocks, actually.
Oh, okay.
And it returned to Earth in 2010 with just micrograms of asteroid dust.
Micrograms. So like basically nothing.
Tiny, tiny amount, yeah.
But still it proved it could be done.
Exactly. It proved that it was possible.
Wow.
And that paved the way for, even more ambitious missions like its successor, Hayabusa 2.
Okay. Hayabusa 2.
All right.
Hit me with the details.
So this one launched in 2014.
Okay.
And it went for a C-type asteroid named Ryugu.
Yeah, okay.
Now, C-type asteroids are really interesting because they're rich in carbon
Okay.
and, importantly, water.
Wait, water and space? Wow.
Yeah.
It changes everything.
It does. Think about it.
Yeah.
Water can be split into hydrogen and oxygen,
Okay.
which are essential for rocket fuel. So imagine if you could like refuel in space instead of having to haul all that fuel up from Earth.
Oh my gosh, that's amazing.
Yeah, it's a game changer.
Totally mind blown.
Yeah, so Hayabusa 2 went for this, water-rich asteroid.
Yeah.
And it actually collected both surface and subsurface samples
Oh, wow.
to give us a more complete picture of like what Ryugu is made of.
Okay.
And it returned those samples to Earth in 2020, and they're still being studied today.
Wow. So Japan's busy with the Hayabusa missions.
Oh.
What's NASA up to at this point?
So NASA was hard at work on their own sample return mission called OSIRIS-REx,
Okay.
which launched in 2016.
Gotcha.
And it targeted another C-type asteroid, Bennu.
So they're in on this space water hunt too.
Absolutely.
Right. What made OSIRIS-REx stand out?
Well, it actually brought back 1/4 kilogram of Bennu,
What?
which is a huge leap forward compared to those earlier missions.
Wow, from like dust particles to like a handful of rock?
I don't know, right?
That's pretty amazing.
It shows you how far our sample retrieval tech has come.
Yeah, that's awesome. All right, so what did we learn from these Bennu samples?
So one of the most exciting findings was that there were actually hydrated minerals present in the sample.
Oh, wow.
So that basically confirms that water is locked up within these asteroids,
Right.
which makes this whole idea of, space-based resource utilization even more appealing.
Yeah, I mean, we've gone from like looking at asteroids from afar to actually bringing back pieces of them.
Right.
Were there any missions that just focused on like scouting out these resources?
You bet. That's where missions like NASA's Dawn come in.
Okay.
It studied Vesta and Ceres,
Okay.
which are two of the largest objects in the asteroid belt.
Wow.
And what it found was just incredible.
Right. I'm intrigued. What did Dawn uncover?
So on Ceres, it detected water-bearing minerals.
Oh, wow. So more evidence for that space water idea.
Yeah, exactly. But on Vesta, it found something totally different.
Yeah.
Evidence of a metallic core.
Wait a minute. Like a whole core made of metal? What does that even look like?
Yeah, so Vesta is essentially this giant metallic asteroid,
Wow.
potentially loaded with iron, nickel, maybe even precious metals.
Oh, my gosh.
And it really just changed our entire understanding of, what kind of resources are out there.
Wow. So it's not just about the water anymore. We're talking about like the building blocks of civilization just floating around out there in space. That's incredible.
Yeah, and while the Rosetta mission was mainly focused on a comet,
Okay.
it also gave us some valuable insights into volatiles and organic materials that are present in these small bodies.
Interesting.
And that's, crucial for this idea of in situ resource utilization.
So using what we find in space to make stuff in space.
Exactly.
That's awesome. All right. So we've covered a lot of ground here.
We have.
From those early flybys to the sample return missions.
Yeah.
And even these prospecting missions.
Uh-huh.
But what about the future of space mining? What's next?
Well, the future is even more exciting. We've got
see.
some incredible missions coming up, and we've got new players entering the game.
Really?
It's about to get really interesting.
Buckle up, everybody. Hashtag TTS The Deep Dive, episode 2024-1208, part 2 of 3. Okay, so we've laid a lot of groundwork here, talked about all these really cool missions.
Yeah.
But what about the future of space mining? Like, what's coming up next?
So NASA has this mission in the works that sounds like something straight out of science fiction.
Okay.
The Psyche mission.
Psyche. Okay, I like it. Tell me more. What's the target?
So Psyche is going after Asteroid 16 Psyche.
Okay.
And this thing is unlike anything we've ever seen before.
Really?
Yeah, scientists think it might actually be the exposed metallic core of a protoplanet,
Whoa.
which is essentially like a planet that never fully formed.
So we're talking about a solid metal asteroid.
Pretty much, yeah.
Like the entire thing.
The entire thing. And we're not just talking like any metal.
Okay.
We're talking about iron, nickel, maybe even precious metals.
Whoa.
Like,
Yeah.
some estimates suggest that Psyche could be worth more than our entire global economy.
Wow. That's almost impossible to comprehend.
It's a lot of money.
So what are like the main goals of the Psyche mission?
So first off, they want to confirm, is Psyche actually metallic?
Okay.
And if so, what's it made of?
Makes sense.
This will help us figure out like how viable it would be for mining.
Okay.
And second, they want to learn more about how planetary cores actually form, which is something we can really only do by studying, an exposed core like Psyche.
So Psyche could rewrite our textbooks on planetary formation.
It could, yeah, it's pretty amazing.
When is this mission happening?
So it's actually scheduled to launch next year in 2023.
Oh, wow. That's soon.
Yeah, and it's carrying some seriously impressive tech.
Oh, yeah.
Yeah, like it's got an advanced optical communication system.
Okay.
So it can send back data super fast.
Wow.
And it's using solar electric propulsion, which is really efficient for deep space travel.
Hold on. So we're going to get like crystal clear images of a giant metal asteroid sent back to Earth almost instantly.
Pretty much, yeah.
That's next level stuff.
It really is.
Okay, so Psyche, that's pretty wild. What else is on the horizon?
So the European Space Agency, ESA,
Okay.
they've got a mission called Hera in the pipeline.
Hera, another cool Greek mythology name. I'm liking it.
Yeah.
What's Hera going to be looking at?
So Hera is headed for a binary asteroid system,
Okay.
Didymos, and its smaller companion Dimorphos.
A binary system, so like two asteroids orbiting each other.
Exactly.
That's wild. Okay.
And Hera's main mission is to study the aftermath of NASA's DART mission.
DART, remind me what was DART all about?
So DART was all about planetary defense.
Right.
It intentionally crashed a spacecraft into Dimorphos.
Right, like as a test to see if we could knock an asteroid off course.
Exactly.
Right. Okay, so is Hera like just going in to check out the crater?
Well, it'll be doing that.
Okay.
But it's also going to be gathering data on the properties of both Didymos and Dimorphos.
Gotcha.
And, this information could be really valuable for planning future mining operations.
So even planetary defense missions can contribute to our understanding of space mining.
Absolutely. It's all connected.
Wow, that's pretty cool. Okay, so Hera's checking out the aftermath of DART.
Uh-huh.
It's also going to be deploying some autonomous CubeSats.
Right?
CubeSats, those tiny little satellites.
Mm-hmm.
What can those even do in a mission like this?
So they might be small, but they're becoming really important for space exploration.
Okay.
Because they're relatively inexpensive and they can be deployed in swarms.
Swarms.
Yeah.
Okay, you mentioned swarm robotics for space mining earlier.
I did.
Can you tell me a little bit more about that?
Yeah, so imagine swarms of robots all working together to mine entire asteroids.
Whoa,
It's one of the really exciting possibilities out there.
that's pretty wild.
Okay. Yeah. But before we get too far into the future,
Okay.
let's talk about the private companies that are, joining this space mining race.
Oh, private companies. This is starting to sound like a sci-fi movie.
I know, right?
So which companies are kind of leading the way here?
So one that's been making a lot of noise is Planetary Resources.
Planetary Resources, okay.
And they're focused on developing, the technologies that we need to actually identify and extract resources from these near-Earth asteroids.
So they're like the space age prospectors.
Exactly.
Right.
And they actually even tested a satellite called ARKY-D3,
Okay.
which demonstrated some key technologies for asteroid observation.
So they're not just talking the talk, they're putting tech up in space.
Right. They're actually doing it.
That's awesome.
And they're also looking into using those CubeSats
Oh, wow.
for prospecting.
Okay.
So imagine like swarms of tiny satellites all scouting out, the best asteroids for mining.
That's a really cool idea.
Mhm.
Are there any other private companies kind of making a splash in this field?
So there was another one, Deep Space Industries, or DSI.
Okay.
And they were really focused on developing the mining technologies themselves,
Okay.
particularly for extracting water for propellant production.
Wait, those space gas stations we were talking
Right.
about. So are they like up and running?
So sadly, they ran into some funding problems,
Oh, no.
and had to shut down.
Ah, too bad.
Yeah, they were working on a CubeSat called Prospector X to test out some asteroid mining tech,
No.
but it never actually got off the ground.
No, that's too bad. But it sounds like that dream of like space-based propellant production is still alive.
Oh, yeah, definitely.
Okay, good.
And, all of these missions, both the public and the private ones,
Yeah.
they've driven some really remarkable technological advancements. I mean,
Uh-huh.
we're not just talking about rockets and spaceships anymore.
Okay, I'm all ears. What kind of tech are we talking about? What are some of the breakthroughs that have come out of these missions?
So the Dawn mission really showcased the power of ion propulsion,
Okay.
which is incredibly efficient for deep space travel.
All right, break it down for me.
So think of it like this traditional chemical rockets.
Okay.
They're like sprinters. They're powerful,
Okay.
but they burn out really quickly.
Right.
Ion propulsion is more like a marathon runner.
Okay.
It uses very little fuel, but it can just keep going and going,
Yeah.
which is perfect for, those long hauls out to the asteroid belt.
So slow and steady wins the space race.
In this case, yeah.
I like it. Okay, so ion propulsion, that's cool. What else?
And remember those autonomous navigation systems we talked about?
Yeah.
I mean, they're becoming incredibly sophisticated.
Yeah.
It's pretty amazing to see how missions like Hayabusa 2 and OSIRIS-REx were able to, rendezvous with and maneuver around these irregularly shaped asteroids.
Yeah, I mean, it's not like landing on the moon where you've got this nice flat surface.
Right.
So how do we even land on these wonky asteroids? And how do we grab a sample?
Yeah, that's where those autonomous navigation systems really shine.
Okay.
They have to be super smart to handle the irregular shapes and the weak gravity.
Right.
And for grabbing samples, OSIRIS-REx actually used something called the Touch-and-Go Sample Acquisition Mechanism, or TAGSAM.
TAGSAM, it even sounds cool.
Yeah.
What is that?
So it's basically like a reverse vacuum cleaner.
Okay.
It uses a puff of nitrogen gas to stir up surface material and capture it.
Oh, wow, that's so cool. And what about Hayabusa 2? Didn't it like grab stuff from beneath the surface?
It did, yeah. Hayabusa 2 used an impactor
Okay.
to blast a small crater, and then it collected material from that exposed subsurface.
Wow, that's really clever.
Yeah, these engineers are coming up with some ingenious solutions.
They are, seriously. Okay, what other tech should we be excited about?
There's so much. Surface robotics are becoming increasingly important.
Yeah.
Rovers and impactors that can actually explore and gather data right on the surface.
Yeah.
And remember, Psyche's super fast optical communication system.
Yeah.
That kind of technology is going to be essential, for sending back huge amounts of data from these future missions.
Yeah, it's really mind-blowing to think about all these advances,
Yeah.
from those first tentative steps to actually retrieving pieces of asteroids and now all this amazing technology.
Mm-hmm.
It feels like space mining is like becoming a reality.
It really does.
But like with any, grand endeavor, there are challenges that we need to overcome.
Right.
Okay, so let's talk about those. What are we up against when it comes to space mining?
Well, remember how Hayabusa lost some of its sample because of a mechanical failure?
Yeah.
I mean, space is a really harsh environment,
Right.
and things don't always go as planned.
So having backup systems is super important.
Absolutely.
Okay, what else?
And the nature of asteroids themselves presents some challenges.
Yeah.
Landing and handling materials on objects with irregular shapes and weak gravity is really tricky.
Right. It's not like landing on the moon.
No, it's a whole different ballgame.
Okay, that makes sense. What about, our ability to figure out what these asteroids are made of before we even go there?
Yeah, that's another area where we really need to improve.
Okay.
We need better remote sensing technologies
Okay.
that can accurately identify and characterize resources from a distance.
So basically like a super-powered telescope that can tell us what an asteroid is made of before we even send a mission.
Exactly.
That makes sense. Okay, so despite these challenges, the future space mining, it sounds incredibly promising.
It does.
What other exciting possibilities are out there?
Well, one of the mind-boggling concepts is, the use of swarm robotics for these large-scale mining operations.
Right.
So imagine, swarms of robots working together to mine entire asteroids.
Whoa.
And then there's the potential of advanced 3D printing.
Oh, wow.
Using in situ resources to build structures right there in orbit.
We're talking about like a whole space-based industrial revolution.
Yeah, it's really exciting.
The possibilities seem limitless.
They do. And another factor that could really revolutionize space mining is the cost of launching payloads into space.
Okay.
If companies like SpaceX can significantly reduce those costs,
Right.
it could open up this whole new era of accessibility for space mining.
Wow. Okay, so now my mind is officially blown.
Good.
This isn't just about extracting resources,
Right.
This is about expanding our capabilities as a species.
Uh-huh.
Pushing the boundaries of what's possible, it's incredible.
You got it. And as we continue to explore and understand the resources available to us out there,
Yeah.
those possibilities only become more exciting.
All right. Hashtag TTS The Deep Dive episode 2024, 1208, part 3 of 3. Wow, it feels like we've only just scratched the surface,
Yeah.
We've gone from those early missions to all the crazy advancements happening right now.
Right.
And then there's this mind-blowing future ahead of us.
Yeah.
It's a lot to take in.
It is. And as we kind of wrap up our deep dive here into the world of space mining, I think it's worth taking a minute to, think about what we've learned.
Yeah, definitely. I mean, we've seen how far we've come from those basic flybys to actually retrieving samples from asteroids.
I know, it's amazing.
And technologies evolving at this crazy pace.
Yeah.
And now we've got private companies jumping into the game,
Right.
bringing this whole new level of energy and innovation.
It's pretty exciting.
It is. And we've talked about some of those really exciting possibilities,
Yeah.
like swarm robotics and 3D printing in space.
Uh-huh.
It feels like we're on the cusp of a whole new era
It does.
of space exploration and resource utilization.
Yeah.
It's super inspiring.
Yeah.
But I also keep coming back to those challenges that you mentioned.
Right.
Space is a harsh environment.
It is.
And working with asteroids is not easy.
It's not like landing on the moon.
No.
Yeah.
So how do we balance that excitement with the reality of those challenges?
Well, I think, we need to be realistic about the challenges,
Okay.
but also optimistic about our ability to overcome them.
Okay.
I mean, remember, not that long ago, the idea of bringing back pieces of asteroids seemed like science fiction,
Right.
and now it's a reality.
Yeah, that's a good point. Human ingenuity is pretty remarkable.
It is.
So what does all this mean for our listener?
Yeah.
What should they take away from this deep dive into space mining?
Well, I think the biggest takeaway is that space mining is no longer just this futuristic concept.
Yep.
It's happening now.
Yeah.
And it's going to continue to evolve, in ways that we can't even imagine.
Right.
We've learned about, these incredible missions and the cutting edge technologies and the really ambitious goals, that are driving this field forward.
And we've touched on those big questions too that we need to address as we venture further into this new frontier.
Yeah.
Thinking about the environmental impact, the sustainability of space resources.
Absolutely.
How we can make sure that space mining benefits all of humanity.
Yeah, it's an ongoing conversation.
Yeah.
And it's one that everyone needs to be a part of. Scientists, engineers, policymakers, the public.
Yeah.
The future of space mining is something that we're all going to be shaping together.
It's exciting to think about what we might be able to achieve in the coming decades.
Yeah.
Will asteroid mining become commonplace in our lifetime?
It's a good question.
What other groundbreaking discoveries are out there waiting for us in space?
I don't know, but I can't wait to find out.
Me neither.
And as we conclude our deep dive, I encourage you to keep exploring this topic.
Yeah.
Keep asking those questions. Keep looking up at the stars with a sense of wonder and possibility.
Beautifully said. The future of space mining is like unfolding right before our eyes.
It is.
And it's a journey that promises to be like as thrilling as it is transformative.
Absolutely.
Thanks for joining us on this deep dive.